Hello. Thank you. So yes, I'm Neil Levine. I've been with Red Hat for a couple of years. I came over with an acquisition of a company called Inktank, who were behind the Ceph project a couple of years ago. And I work in the storage business unit at Red Hat. And many people don't know that Red Hat is in the storage business. Just like sort of Microsoft is still associated with Windows and IBM with mainframes and Oracle with lawyers. Red Hat is still primarily seen as a Linux business, but we actually have a very strong and vibrant storage portfolio, and I'm going to tell you a little bit about that today. So first I'm going to sort of explain which part of the storage market we sit in, which is a software-defined storage market, give a little bit of our overview of our portfolio without doing too heavy a sales pitch. And then I mainly want to focus on, with the theme of the conference, some of the converged and hyperconverged solutions we're doing, mainly with containers and OpenStack. And then I'll give a little bit of props to our sponsors here, QCT, and explain what we've done with them. Okay, we have to do the navel-gazing, what is software-defined storage? This is a great slide. We like this inside Red Hat. It contains every single successful buzzwordy kind of thing that's happening right now in the IT industry. So very popular with our marketing team. But what this slide is supposed to show is that there's a lot changing everywhere in IT infrastructure, whether you're on the development side, the operations side, infrastructure management, whatever it is, things are changing everywhere, which is exciting for us in the IT industry. And software-defined storage is also part of these changes that are going on. And the common drivers behind all of these are that we're trying to have faster development, faster deployment, better quality, and ultimately to get things of higher quality out to customers quicker. It's the millennial, I want things now, I'm used to an app store experience, and all of this is really designed to fulfill that. And storage has a role to play as well. Storage has traditionally been the slowest, most sort of static part of the infrastructure, but now with software-defined storage, that's changing. So what is it? So we have a particular sort of perspective on this, as you'd appreciate. And of course, most importantly, given we're at a QCT event, the most important thing is that we're taking the intelligence of the software and abstracting it away from the hardware. So in the old world, we used to have big proprietary tin with embedded sort of ASICs and sophisticated proprietary software. And now we're moving to a world where it's a pool of off-the-shelf x86 servers, which we consider to be sort of this heterogeneous sort of set of resources which we can partition as and when we need to based on the requirement we have from the end user. So this is really valuable for end users because you now get great economies of scale when you're purchasing standard off-the-shelf x86 equipment for your storage as well as for your compute. And ultimately, it's designed to give faster, more flexible configurations to the admin and ultimately to the end users. So we have off-the-shelf servers, and of course, this then really speaks to what we see now in operations, which is an elasticity of scale, without having what we used to have on the top there, which is a big piece of tin sitting doing nothing whilst I waited to fill it out. Or often I was moving data around between these big pieces of tin, which is an operational headache. So now you can scale the compute and the storage together, and not just in terms of the actual physical equipment that you're rolling out, but also in terms of how you're provisioning these things can be the same too. You're going to use the same scripts, the same interfaces, the same APIs for both the compute and the storage. So abstracting out the software from the hardware really gives you some instant benefits. Of course, you also need the storage piece as well. And above and beyond just having the storage smarts of persisting the data, with software-defined storage, you get a complete programmatic interaction with all aspects of the storage system, from provisioning it, configuring it, and ultimately managing, monitoring, and sort of doing diagnostics on it. So now we have everything visible programmatically through software. So again, huge benefit for the admin, should make things a lot easier, but also ultimately benefit for the end user. You're able to fix and identify and fix things much quicker as a result. And then finally, and this is definitely the Red Hat spin, we like to see an open ecosystem. If the whole point of software-defined storage is better quality, and faster innovation, and faster deployment and everything else, we think the only way you really truly get that is with a complete open source stack. And this is our big differentiator with some of our friends here at this event today, where we lead open source ecosystems building this tooling. So we have two communities which we participate in and lead, called Ceph and Gluster, both very vibrant communities. But ultimately, these communities allow us, using the open source model, to bring in innovation very, very quickly, much more rapidly than you get with a proprietary model. So we have not only people like QCT, but Intel and other hardware manufacturers enabling their components and the latest generation of hardware in an open source technology first. Okay, so what does this all mean? It means we get away from these silos of proprietary tin to a commodity set of machines in a pool where we have a flexible software layer on top with no sort of intermediation through the admin. It's all done through directly by the user. I think it was a question?
Two questions, if it's okay. If you're going to address them, I'm coming back to it. What would I use? I'm guessing both Ceph and Gluster or software-defined storage, right? What would I use Ceph or
you know something, you've set me up, we should be on radio together, you've set me up to explain what the difference is, which is the number one question we get. So you had a second question, which was?
The second question is, right, earlier today, right, one of the keynote speeches, there was Gopal Krishnan or somebody from Headway, right?
Yes.
So how does, I don't think their product is open source.
Correct.
Right, so what is the difference between, when would I think about me as a customer, right? When would I go talk to them versus doing this for Gluster?
Okay, so let me answer the second question in a bit. I'm going to answer your first question first, which is, yes, the most common question. You've got two software-defined storage products, what, where, and when. So they have a lot of commonalities from a sort of a 30,000-foot level. They're both scale-out. They are both distributed, share-nothing systems. They self-heal, they self-manage, all of the sort of goodness you now want from storage software that works as a distributed system. And they all work on a range of x86 platforms. So that's a commonality. But the difference is the architectures are very, very different. And because the architectures are very different, they lend themselves to different use cases. And so no different to any other storage vendor who has a range of machines that they then position for different market segments and different use cases. We do exactly the same thing. So this slide here, the second most popular slide in the storage business unit after our buzzword slide, tries to show how we align different products to ultimately what is the big differentiator that Red Hat has, which is we often integrate these products with other parts of our portfolio on the compute or development side. So if you're just looking to deploy a standard storage system, perhaps for scale-out object storage or scale-out file storage, you would run it on bare metal, just on top of RHEL, our operating system, and really you're choosing it based on a protocol. But really the difference is when you start to look at, am I trying to build an environment for application developments, perhaps with around containers, which is our OpenShift platform, or am I looking to do a cloud environment based on OpenStack, then because of the architecture of the software and the integrations they have, they lend themselves very well to those different use cases. And in fact, that's sort of what I'm going to dive into now, is that for these things in the middle where they do hook into these other bits of the stack, that's where we converge them or hyperconverge them to sort of really fuse the technologies together so they ultimately look like one product or one solution that you're rolling out. But just to finish off on the far right there, we do, for example, position Gluster as a solution on top of AWS for a file as a service. Amazon does have a very good object and block interface, but its file service is pretty expensive. You can only run it on SSDs. That's not what a lot of customers want. They want a more price competitive solution. So that's where Gluster would come in. But I'm going to focus predominantly on the containers in the private cloud, mainly because they're sexy and they seem to be what people stay awake for, whereas you go into the other stuff and eyes glaze over. Okay, so let's focus on containers. And this is where we primarily position Gluster. So containers have gone through the same journey that OpenStack went through over the past 5 years, which is you position it as this cloud native, I'm going to do greenfield applications, it's all stateless, 12-factor apps, all these kind of new paradigms. But the first thing you hit into is that I actually still need to store data somewhere. And people realize this very quickly with OpenStack, which then gave us Cinder and all of these other services like Manila. And the container world has gone through exactly the same thing. Once the developers have finished with their prototype app, they realize I need to persist the data. How do I do that? And so what this chart shows is that all of the applications that people are really looking to put into production are data intensive. They're not stateless kind of ephemeral systems. These are actually generating data, often with a database. So OpenShift, which is our container management platform, it's built of a number of different components. One of the most important ones is Kubernetes. Red Hat is a big contributor to the Kubernetes community. Then out of the box with that, you get a whole bunch of drivers for connecting to storage systems, not just Ceph and Gluster, but actually standardized SCSI or Fiber Channel or even EBS if you're running this thing on top of Amazon. So out of the box, just by using the OpenShift platform, you can use a variety of storage systems. But again, a lot of those, as I showed you earlier, not really what you want for an elastic scale-out, brand new Mode 2 or third platform, whatever you want to call it, for a new environment. And this is where we're now saying that Gluster is actually the ideal solution for that because it actually has a very lightweight, very flexible architecture which really lends itself well to containers. And in particular, it's a file-based product, which is really what containers are natively consuming at the moment. They have a very file-centric view of persisting data. So the first step of what we did was we allowed you, if you're running, say you were running containers and you'd gone through this experimentation, you've got your application, your web server, whatever it is, we allowed you to plug either of any of our storage technologies into it. You can persist the data to an external storage cluster, in a sort of classical two-tier model of compute and storage being separate. So through these Kubernetes drivers, which we ship, they're baked into all the Kubernetes software, you get them for free, you can just plug that into an existing storage system. But we've now taken that one step further, and because, again, Gluster is actually quite a lightweight, very sort of malleable system, we've now containerized Gluster itself, so you can actually run Gluster as a containerized application. So this is why people go, why has Red Hat got into the storage business? Well, for us, storage is now just another Linux application as far as we're concerned. And this is where we're containerizing it into a format that you can run on top of RHEL or our new container-centric operating system, which is RHEL Atomic. But we've now gone even further, and this is where we feel we've got a truly sort of innovative platform where you can actually now manage that Gluster application as a Kubernetes sort of ingredient, that actually you can use Kubernetes to not just control the application that you've written, but also to manage and control the storage as just another peer app on top of the container management platform. So in this way, you can actually have what we call container native storage or container converged storage, where you've got the app and the storage running together on a node, and you scale out those individual nodes, and you get both the compute and the storage at the same time. So you can really scale them together. You can still have a separate storage tier down at the bottom if you want to, but for most people, they're content to just get going with that sort of converged, hyperconverged system at the very beginning. So unified orchestration, unified rollout. On the roadmap, we're going to have dynamic provisioning coming up in the very near future. So as you spawn an extra compute and you tell it you need storage, it'll provision automatically the pools for you, connect them all up to the pod of the application pod and so on. So we're very excited about this solution because we're one of the few vendors who are delivering both the operating system and the storage and a container management platform. It's all open source, but all shipped as an integrated stack from Red Hat. So you were talking about what's the difference between us and the others. Red Hat's sort of differentiator, as you will, is that we're not just selling the storage, we actually have other things which are really fusing in deeply. So you get the sort of cliche one throat to choke, but you also get, we've got really, really rigorous QA going through that entire stack, going through the upgrade cycle, trying to make it as simplified as possible. Because ultimately, that's what hyperconverged is. There's lots of definitions, but really it's about making life easier for the admin, and that's what we're trying to do here with this container native storage platform.
Can you stretch storage across two physical sites?
So yes, you can. You can split there are some, there are caveats to how you're doing that, but yes, you can move things between sites and spread the cluster between them. So yes, if you want to do a disaster recovery mechanism or a follow the sun thing, then that's certainly possible. So this is our container converged story. So, but next, let me move on to where Ceph predominantly fits in. Ceph has got sort of two major use cases, which is the object storage side, which we've actually done a lot of work with QCT about these really big, high-density boxes to sort of get you object storage. But the other part where Ceph has been very popular has been OpenStack. And again, it comes back to an architectural story, which I'll come to in a second. So Ceph has been the #1 storage system for OpenStack consistently year after year for a number of years now based on the OpenStack user survey. It was actually, it's been open source since the very beginning, and so the journey was you had a lot of cloud administrators who said, I've been given a mission to deploy an open source elastic infrastructure. Well, I'm not going to pick a sort of an open source cloud platform and a proprietary storage. The whole thing needs to be open. And so again, Ceph got brought in there. But ultimately, the reason it was so popular was not just the open source nature, it was also the features it gave and the value it gave. And the diagram here on the right sort of speaks to one of the unique aspects of Ceph, which is it is plumbed in deeply into all of the aspects of OpenStack. And most storage vendors have done a Cinder driver, Cinder being that persistent storage control interface. And you write a plugin for it, and that's it. That's their OpenStack story done. But Ceph has always gone one step further than that. So we actually, yes, we do integrate with Cinder. In fact, we were the reason the Cinder sort of project initially got incubated to a certain extent. And so we can provide you persistent storage, but we also integrate into the hypervisor and to Nova, so we can actually do the ephemeral storage for the virtual machines as they're being instantiated. And we can also back the image store, which is Glance. And we can do the object storage. Wow, 5 minutes left, I've got to speak quickly. Plus, we can also do the object store. So we plumb into everything, and actually now we've just released an integration for Manila for the file system. So you get object, block, and file, all plumbed into all of the control plane services. And the reason we were able to do this is because it's open source. And because it's open source, it's not just us as InkTank or now Red Hat doing that plumbing. There's a huge community maintaining those drivers and integrations. So the actual admin benefit or the end user benefit is you can spawn 1,000 VMs pretty much instantaneously because the image is stored in the image registry. We do a copy on write clone for 1,000 VMs. The VM boots as quickly as it can, but the storage is there immediately. And you can move this data back and forwards with zero data being moved across the wire. It's all done on the Ceph cluster. There's no iSCSI kind of pulling it in and out. It's all transparent to the end user, done natively at the storage cluster. So deeply wired in and ultimately giving you very, very fast, responsive VM storage management, as well as object or file if you need it. And block, yeah. So block is the main one. So when it's kind of obscure, RBD or librBD. RBD is a Rados block device. That's the principal thing that people are consuming for ephemeral and persistent storage and for the image store. It's wiring it all three together, gets you this dynamic movement. So you can boot it off of Glance, get it into an ephemeral instance on Nova, snapshot it, have that snapshot stored back in the image catalog, or take that snapshot and boot a new machine off it, and you can just pretty much move this data around as when you want, and it's instantaneous.
So how do you, can you explain a little more about that, the ephemeral portion of this?
So when you boot a virtual machine in OpenStack, it needs some storage for the operating system. Right. And so that's what in OpenStack they call that's the ephemeral storage. And so because we are plumbed into KVM here, where librBD is essentially a user space library compiled into KVM, you can actually have the VM backed by a Rados block device for that ephemeral VM storage. So when you shut down the VM, the block has disappeared. So initially a lot of people, they don't need persistent storage. They just want a VM to do whatever they do with it, and they shut it down. Some people boot it up with ephemeral storage backed by Ceph, and then they want to attach a persistent store to it as well, which is also in Ceph. Or maybe they want to take what was the ephemeral VM and say, no, I want to keep that because I've put a whole bunch of very important data. I want to clone it. I want to snapshot it. I want to maybe turn it into a new golden image I'm going to boot off other machines off in future. And so because that's connected up to Ceph, we've already got a copy. We say, OK, it's now becomes a new golden image or becomes a persistent image. We can manipulate all of that in the back end. And all of the OpenStack services know about that immediately as well.
Well, one of the other reasons to use ephemeral storage is for high I/O operation, like a standard database.
Right.
So, going through the Cinder interface will majorly slow it down.
So it doesn't go through Cinder. When it's ephemeral, it's just a direct connection between a hypervisor and Ceph. But yes, it's a network storage system, so it's slower than direct attached. But not everybody wants to run expensive disks in there as a direct attached on all of the compute nodes. So a lot of them, if you can reduce the cost of the actual compute heads by saying, I don't need to have that much ephemeral storage. I really need enough to get a hypervisor up and running, and that's it. And so that's for a lot of people, that's very compelling because they're not all running Cassandra and everything else which needs direct attached. Yes?
So two questions. One is the hypervisors that are in the physical layer. do they have to be like for like? So do they have to be exactly the same, or could they be, could have two similar nodes and they be added to the storage? Second question is, when you create the storage, how much overhead do you have and how much storage do you lose when you create the storage cluster?
So I'm sorry, I'm not sure I understand the first question, which was, sorry, could you just repeat the first question again?
The first question is, do the hypervisors have to be like for like?
What does that mean when you say, do you mean they have to all be KVM, or you can have sort of...
They all have, like, do the hypervisors physically have the same?
No, you can have completely, you can have whatever you want to. So yeah, it's completely, as long as it's running KVM, we can plumb into it, then Ceph is very happy. We don't really care about the hardware configuration at that point.
Okay. And when you add different nodes, their storage into the cluster, how much overhead, like how much storage do you lose for like, you've done like a day?
Oh, I see. So that's user, time's up and I've got a few more slides. It's entirely user configurable based on how many replicas, erasure coding, and so on and so forth. Let me very quickly get through because I've got to do the sales pitch, right? I mean, otherwise I'm not earning my keep here. So what are we doing with OpenStack and Ceph? We're hyperconverging them. Why would you do this? Save money on hardware with POCs. NFV is the big one. Telcos are very, very interested in OpenStack. And that's really the biggest use case and the biggest driver we're seeing now, more so than enterprise. This is like looking at the sun. Don't stare at it for too long. It's an OpenStack architecture diagram. It's used to frighten small children with. But the point I'm trying to make here is it's really hard to converge OpenStack because it's got so many services. So this is where we've really come in and looked at all of the components of OpenStack because we're a huge developer around it, and for Ceph as well. And this is a new hyperconverged OpenStack environment we have where we've got two tiers. One where you're hyperconverging the control plane, or the OpenStack services, and there are a lot of them, with the Ceph monitors, which are essentially the sort of the control plane as well for Ceph. And then a second tier below where you're converging the compute and storage. And this can be shrunk down to essentially a half rack in a cabinet in a remote data center for a telco. And this is why it's really appealing for them. It means they can get rid of expensive proprietary black boxes. And in the open source business, we love getting rid of proprietary tin. So this is what we're trying to do. All right, I've really got to just do this because I like being gracious to my host. Thank you, QCT. We've done amazing work with you. We love you. You've got great configurations. We can make things go super, super fast. It comes back to direct attached storage. We can even almost get as close as that. We have a range of off-the-shelf SKUs of QCT, both for Ceph and for Gluster, ideal for these type of solutions. And we also are working, final slide on a solution center here. If you want to come in and validate any ideas or solutions you have, please come and talk to us. QCT being a great vendor. I'm not saying that because I've been asked to be here, but I've really enjoyed working with you. You're a lot more fun to work with and very committed. So thank you very much.